Okay, good morning, everybody. Welcome to Math 201, Calculus 1. Looking forward to working with all of you this semester. One quick note to start, I sent this email out, but in case you didn't get it, on your schedule, it says that our class meets 10 o'clock to like 10:39. Plenty of seats back there. Good morning. 10 to 10:39 in North 402, which is the math studio, which is a great place to study and do your homework and work with your classmates and work with the math faculty who's on duty. But it is not technically part of our class. It's just there as an open slot, open to give people a space to work together. Our class officially starts at 10:40, and so we'll start promptly at 10:40 every day. So on the very first day of class, there's lots of logistical things to get to. And again, you've got 5 handouts in front of you. We will explain each of them in turn at some point during today's class. But we're going to start on the big packet, and we're going to jump right in with some math. So here we go. Our daily summary up there at the top. Calculus is the study of change. Today we will see some examples where calculus is lurking behind the scenes. And we're going to start, like any good calculus class starts, by watching a soccer clip. So the clip I'm about to show you is a goal by Wayne Rooney. I'm not a soccer guy, but apparently he's famous in soccer circles. Yes, yes. And the goal we're going to watch was voted to be the greatest goal in the 20-year history of the Premier League. Let's come back and answer some of these questions here. Is 2,000 degrees per second humanly possible, and what does this figure really mean? Can somebody's foot rotate 2,000 degrees in one single second? 2,000 degrees would be about how many complete revolutions? All right, like 360 degrees is one revolution, so maybe around 6. Okay, so could you imagine somebody's foot, leg, ankle, everything rotating 6 complete revolutions in 1 second? That would be quite painful for that person if it happened. So is this figure just bogus, or might it mean something different than we're saying 6 revolutions in 1 second? Yes?
For that split moment, it might have been moving at that rate, but it wouldn't be doing that continuously. It's just that split moment.
Yeah, so this idea of what's happening at one moment in time is going to be something that's a thread throughout our calculus course. When we say 2,000 degrees per second, well, a second is a really long time in some contexts, and we're not talking about a full second's worth of time. Maybe we look at like half a second. If that rate were constant, then how many degrees in half a second? Half a second, go the other way. If that's 2,000 degrees in a full second, then 1,000 in half a second. What if I'm looking at a tenth of a second? 200 degrees in a tenth of a second. I could look at like 100th of a second, and that would be 20 degrees. Okay, 20 degrees is something that's reasonable, right? Like I can move my foot or my hand at 20 degrees. So the question is, if we keep kind of like honing in on the moment of impact, like can we just look, I was trying to slow it down, we could slow it down even more, especially with the higher quality clip, and maybe just like freeze frame it and just look at one little teeny tiny, like 100th of a second, did his foot go 20 degrees, or maybe even smaller time period than that, and that's what we're talking about. So we're not suggesting 2,000 degrees in an entire second, but if we just look at the moment, really teeny tiny time interval, yeah, that instantaneous rate of change, maybe it's viable. Okay, so how might this number have been calculated? Maybe by, like kind of freeze frames or smaller and smaller moments of time, just really honing in on the one moment we're interested in. That was the moment of impact. And here in part C, and so I'll add one more thing here, tiny time intervals. Come on in, welcome. There's an empty seat way back there. You want to grab that one? Okay. All right, so part C, rates of change, and in particular, instantaneous rates of change are at the heart of Calculus 1, and we will be seeing them throughout the course. Number 2 says we're going to have a look at an Excel file which has to do with plant growth. All right, so this Excel file is really cool, and it's awesome what Excel can do, but this computer is too slow for my little animation to work, and it's not going to work. So I have to describe this thing to you, but trust me, it's awesome on Excel. Okay, so we are imagining planting a little seedling, a seed that's going to grow up into a big tall plant. So I'm going to plant this right here in the ground, and I'm going to start my stopwatch, and this thing is going to start growing. And so you're going to imagine in your mind a plant growing from no height at all, a height of 0, and it's going to grow slowly in the beginning, and then it's going to grow more rapidly, and then it's going to grow slower again at the end. And in fact, that's kind of how a lot of things grow. For example, you had periods in your life where you grew quickly, like early on, and then as your height kind of leveled off at like whatever your adult height turned out to be, you were still growing, but slower and slower and slower. So imagining that scenario with our little plant starting from a height of 0 and then growing slow and then fast and then slow, I would like you to take a moment right now and see if you can plot the height of the plant on this vertical axis against the time passing. So we start the clock right when I plant this seedling in the ground at a height of 0. So that should give you 1 point to start with. And now you're going to try to capture the rate of growth that I described, which was slow in the beginning, and then faster for a little bit, and then slower as it reached its adult height, if that's a word I can use for plants. Okay. Okay, so I'm seeing lots of graphs. If it's okay, if you can't quite picture this, it would have been a lot easier to picture it if I could show you my little animation in Excel. But we talked about how we start the clock when the height is 0, so that's the origin. And then I said it grows. Okay, so grows means it's going up, right? But one of them is growing faster and faster and faster, and the other one is growing slower and slower and slower. And I said we want the one that grows slow and then fast. So which one, top or bottom, is the one I described? The bottom one. So we want something that grows slowly in the beginning and then speeds up. But then at some point it's reached its like fastest growth rate, and then it's still growing, so still increasing, but then slowing down. If you want to be fancy, you could put like a dotted horizontal asymptote up there at the top, right? It's not going to get above some certain height. Okay, and so there you go. Part C, it says, let's mark the special point on our graph above that represents the moment where the plant is growing most rapidly. So one moment, one single dot where the plant is growing most rapidly. Okay, and so yeah, someplace in this like steepest part, for me it's somewhere around there. Yours might be a little bit different, but there's something fancy happening at that one spot where if I think about like the rate at which my hand is kind of going up, like it goes up slow and then faster, 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 and then it's got this like peak fastness moment, and then still going up, but not as rapidly. And so, yeah, that guy right there has a name. The special point has a name. We'll see it formally in a coming class, but we'll define it here, although you might have seen this phrase in pre-calculus. Anybody know the name of that point? There we go, inflection point or point of inflection. Either way. So we'll define that phrase soon enough, but that's what that point is called. And so again, even though like this is different from the soccer clip, to me, it's another example of rates of change. We talked about the way that this plant was growing, and you captured graphically different growth rates, slow and then fast and then slow. We're going to be doing a lot of that this semester. Number 3, all the problems that we tackled today involve calculus, although it won't always be obvious where the calculus is because I've hidden it behind the curtain, and I'm assuming we don't know calculus at this moment. And so just trust me when I say there's calculus behind the scenes. I'm going to pull things out of a hat, and throughout the course of the semester, it will become clear, oh, on the first day, Ian pulled that thing out of a hat, but it's really just easy to do now that we know this calculus technique. Among other things, calculus allows us to find extremes, that is maximum and minimum points. And calculus opens the door for us to understand with great precision the behavior of graphs. So we will see all of that. Okay, so let's take a look at some highlights from the syllabus and some other logistical things. So you should have a document that looks like this. Go ahead and grab it right now. Okay, so there's a lot of information densely packed in this syllabus. Part of your homework for the next couple of days is going to be to read through this and ask me any questions that you might have. I'm just going to go over a few brief things in the syllabus during our class here together. So first, my first name is Ian. That's how I want you to call me. I've given you my work number, I've given you my cell number, and I've given you my email address. Any of those are fine ways to reach me. You should know that when I go home, I do not have access to email. Even if I did, I probably wouldn't check it. So if there's like a test tomorrow and you have a frantic question the night before, email is not a good way to get that resolved. The fact that I'm giving you my cell means it's okay for you to call my cell. Totally fine. I'm giving you some hours there. Sometimes I'll have students who struggle on like one homework problem for an hour, and if they had just called me, I give them like the one little piece of information they were missing, and it's like a 30-second phone call, and then they can do the rest of their homework on their own. So struggle some, but don't struggle so much that like you're just spinning your wheels, right? Call me at some point. It's probably something minor. Okay, next thing to talk about on the syllabus is the textbook. So our official textbook is the 6th edition of Calculus by Hughes, Hallett, and a bunch of other co-authors. The 6th edition, being the current edition, is expensive. The 5th edition is nearly identical to the 6th edition and can be bought for pennies if you know where to go. So it is totally cool with me if you want to save yourself like $140 and buy the older edition. Okay, I will give you homework problems for both textbooks. If you go with the older edition and you order online and you have to wait for shipping, it's no problem. Both editions are sitting in the studio right in that bookshelf across the hall, so you can do your homework in there while you're waiting for your book to get shipped. The library also has a copy of our textbook. You can't check it out, but you can do your homework right there in the library, okay? All right, I think that is good there. Next up in this big document here is way near the back, right here, second to last page. It says tentative course schedule at the top, second to last page. So here is what our semester is going to look like. Today we're at class number 1. I'm going to assign 2 projects today. We'll talk about those. And I'm going to collect those projects on either September 27 or September 29. 2 different projects, 2 different due dates, but back to back, those 2 due dates. Also, quiz number 1 is there on the 22nd. Like if you're into writing things in your calendar, the first test is scheduled for October 4th. It's all there. Give you a sense of where we are and where we've been and where we're headed, okay? Lots of information there. And then on the last page of this thing are the daily homework assignments. So right before class, every day I'm going to check homework from the previous class. So tonight's homework, we're doing class number 1. That's this one on the top left. So if you have the 5th edition, you're going to section 1.1 and doing these problems. If you are using the 6th edition, you're going to 1.1 and doing slightly different problems. And then I'll just show it to me right before class on Friday, and I'll give you a little check mark, and we move on, okay? I have assigned odd numbered problems as much as possible, so you can check your own answers in the back of the book. But please don't just write the answers when you're showing me the homework. Show me the calculus, show me the algebra, show me the work, okay? All right, so lots of details there, and you're going to read through that and come back with questions. Okay, next logistical thing is the math flowchart. You do not have this on your tables, so don't look for it. All right, currently you are in this yellow highlighted course, Math 201. This is the place to be if you are majoring in science or engineering or math, computers, any of those fields, because this particular class opens the door to Calculus 2 and Calculus 3 and linear algebra and pretty much the rest of math. However, we do have another course called Applied Calculus, which all of you could take this semester right here, right now, instead of this one. Applied Calculus is for business majors and like sociology and psychology, the social science type classes. And that might be where you belong if that's your major, okay? So if you're not sure, just talk to me right after class and we'll get you squared away. But anyway, there are 2 options for you right now. We just want to make sure you are where you belong, okay? So see me after class if you have questions about that. All right, we did that, and we did that. Okay, next up. This is project number 1. Go ahead and turn just to page number 2 of project number 1. All right, so this semester, there are going to be 6 math projects plus 1 project where you'll reflect on what you've accomplished during the semester. So it's a project and it counts as a grade, but it's not a math project per se. So 6 math projects. I have just handed 2 of them out to you. It's quite unusual for a teacher to say, hey, here are 2 projects, work on them at the same time. That's what I'm doing here. But I am going to try to give you a way to stay on top of these 2 projects in addition to the, like the homework assignments, the daily homework assignments. So these projects, like I said, are going to be due like late September. So I'm giving you, I don't know, 3.5 weeks to work on these projects. And it's because it takes that long, a little bit at a time. Do not wait until the day before it's due to open this thing up and then realize, oh my gosh, what is going on here? They are challenging, but they are doable as long as you follow the schedule here. So here's the recommended schedule for this project. The other project is the same idea. It's got a different schedule there. So this is class number 1. When we come back Friday, that's class number 2. So what I suggest you have done by the time we start Friday's class is that you read, this is the reading part, you read pages 7 through 9. That is 3 pages of reading. It is not supposed to be overwhelming, but if you wait until the day before and you read all 22 pages the day before, that is going to be overwhelming. And then the exercises that I want you to have done, none, not for that day. Just 3 pages of reading. And then for our next class, class 3 is Monday, I want you to do 3 more pages of reading, and I want you to do number 2B. It's inside of the project. You will find it. If you follow the recommended calendar, you'll be good to go. Don't wait until the last minute. Technically, I'm not going to check any of this until the thing is due, which is class 10, end of September or something like that, right? But I can't stress enough the value of working on it a little bit at a time as opposed to last minute. Almost all of the work that you're going to be doing in this class, you are welcome, encouraged to work with each other, to work with me, to work with math faculty in the studio, to work with a peer tutor in particular. Working on these projects alone is no fun. So find other folks that are at about the same spot as you are on the projects, work through it together. If you get stuck, you got me, you got other math faculty in the math studio, you got the peer tutoring center, okay? All right, let's come back to here, and I think we're good. Okay, and so we're back on the big packet, and we're moving on to page 2 of the big packet. And we'll read this note up here at the top. So we're about to start our first group activities. Here it is. It says the group activities are never collected, but working and struggling through them with your table mates will increase your understanding of calculus immensely. An answer key usually follows the group activities, but check with your neighbors before checking with the answer key. You'll get a lot more out of the conversations you have with each other than just looking at my answer key to decide whether your answer is right or wrong, especially if your answers are different from each other's. That's a good thing from my perspective, not a bad thing. Have the conversations, check the answer key if we're really all stuck, and or raise a flag. That little flag on your table is your way of saying, hey, Ian, come on over. We need a little bit of a push, okay? All right, so the problems start here with number 1. As soon as you finish this page, you're going to move on to the next page. Pretty much that's the right thing to do whenever you finish any page of this big packet. Just turn the page. There will almost certainly be more things for you to try. But before you start number 1, you're going to be working with your classmates all semester. Get to know their names right now. Introduce yourself to the people sitting at your table. Write their names down and then jump into number 1.